In this work we studied development trends and the competitive situation in respect of Metahuman, and proposed a novel analysis framework including the components of product modules, technical topics, and patent data. Since Metahuman involves the integration of advanced technologies, the analysis results may influence technology iteration and innovation in R&D enterprises, industrial development strategies for policymakers, and necessity applications in human lives. Therefore, we discussed issues related to the economic and social aspects of sustainable development. Metahuman is a hot topic nowadays, and current studies mainly focus on the following three dimensions: concept, definition, development history, and application scenarios. However, research on metahuman technological analysis is still in its infancy. Thus, to provide valuable information for promoting the sustainable development of Metahuman, we conducted a patent analysis of Metahuman technology. Scholars have suggested the advantages of using patents to reveal emerging technologies, since patents provide greatly detailed descriptions of the technological aspects. The search results of this research were obtained from the DI, Derwent Innovations Index, patent database, which is a web-based patent information database that integrates the Derwent World Patents Index, DWPI, and the Patent Citation Index, PCI, to provide global patent information. The DI database is a powerful tool for searching worldwide invention patent information and has unique characteristics, in that it takes a series of measures when including patent data from various countries, for the purpose of improving the comprehensiveness and accuracy of patent searches. In this study, cross-country analysis using the DI database provided references for retrieving patents from the DI database for the comparative analysis of countries and guaranteed that the mainstream technical direction and research results provided would be of use to the greatest extent. The discussion of the selected database is useful to ensure the balance and robustness of the data used for analysis in this research. The findings through patent analysis in the time dimension illustrate the total changes, evolutionary stages, and development trends of metahuman technology. The results indicate that the global patent applications related to metahuman are aligned with the R&D history of metahuman, passing through the periods of early stage exploration, rapid development, and the recent peak stage. Due to technical limitations, metahuman in the early exploration stage were not mature enough and the product quality was low. According to the results of annual patent applications, the years of 2000 and 2016 were two key time points marking the milestones of different development stages. The year 2000 became an important turning point in the history of metahuman development due to the presentation of the social practice function of metahuman. Metahuman presented by computer animation is gradually being replaced by metahuman presented by CG, motion capture, and other computer technologies. In addition, the year 2016 has been dubbed the year of artificial intelligence, in which a global AI trend erupted. Breakthroughs in AI technology and deep learning algorithms have led to simplification of the metahuman production process, leading the development of metahuman into a new period. Thus, this research provides objective empirical test results for the evolutionary history of metahuman. The results of analyzing 4 typical patent priority countries provide 2 main insights into national technical competitive advantages. From the time series viewpoint, the U.S. patent applications from 1973 to 2000 reached 21,356 and China came in second with a total of 12,220 patents. The overall number of patents held by the US and China from 1973 to 2000, which accounted for 80.16% of all patents, greatly outstripped those of other nations. The US dominated the metahuman technology sector for decades in terms of overall technical prowess until it was overtaken by China in recent years. From 2017 to 2020, China filed 6,560 patents, 1.2 times as many as the US, 5,449 patents. Thus, China has been leading the development of metahuman technology with tremendous technological advancement during the last 4 years. Since Metahuman is a virtual image constructed by artificial intelligence technology, the development of Metahuman is closely related to the innovation of artificial intelligence. The existing literature indicates that the US has a dominant position in the development of artificial intelligence industries and plays a crucial role in the global development of AI technical networks. The research results show that artificial intelligence industries are also constantly and rapidly developing in China. South Korea and Japan were comparable in terms of metahuman technology, and we observed a small difference in the number of patent applications between these two countries. There would have been a total of 2,378 and 2,151 patent applications in South Korea and Japan from 1973 to 2020. The total number of applications from 2016 to 2020 was 1,047 in South Korea and 769 in Japan. Furthermore, from the technical layout viewpoint, the findings show that different countries present special characteristics at the product module level. Except for character generation and synthesis and display, which were in second place behind China in terms of patent applications, the US held a relatively dominant position in the majority of technology modules. China outperformed other nations outside of the US in the character generation and synthesis and display modules, as well as in the modeling and rendering, intelligence-driven, information collection, recognition and perception, and analysis and decision modules. Our findings fill the gaps in knowledge regarding the technological layout and competitive advantages of dominant countries in the field of metahuman. The analysis of technological change from the modular perspective effectively bridges the product development life cycle and technology evolution. We summarized the emergence and growth of patent technologies related to the following modules through the analysis of patent data: information collection, recognition and perception, synthesis and display, analysis and decision, character generation, modeling and rendering, and intelligence-driven. Additionally, we observed that the technologies underlying metahuman functional modules started with the relatively simple modules of information collection, recognition and perception, synthesis and display, and analysis and decision, and then moved on to the relatively intricate technologies of character generation, modeling and rendering, and intelligence-driven. The research results indicate how technological convergence evolution has taken place from 1973 to 2020. The authors found some prominent technologies that gained significant importance over this period. We also compared our findings with other studies, showing that facial recognition technology, capture-based and synthesis motion, rendering technology, and digital human modeling based on virtual reality are all topics of interest to scholars. However, the intelligence-driven module is hardly mentioned in previous research, possibly because there has been limited exploration of modules in the practical dimension. Our findings provide evidence for reflecting that technological progress is an important internal driving force for the development activities of metahuman. 5.2. Theoretical and practical implications. Major implications of this study are to be found in the methodological and practical aspects of R&D enterprises and policymakers. Unlike many previous studies that identified technical topics, we took a further step and applied an optimized and systematic analysis process, for the purpose of minimizing the possibility of misidentifying emerging technology areas and improving the usability of the research results. FPS was used to build 7 modules for the metahuman product from the dimensions of function, behavior, and structure. Taking patent abstracts as the corpus based on 42,256 patents relating to metahuman, the LDA method was utilized to extract 7 technological subjects and their corresponding patent data. Finally, through expert consultation, it was determined that the product modules, technical topics, and related patent codes corresponded, which provided a solid database for the patent analysis of metahuman technological development. Therefore, the process for recognizing patent data in complex items, which cover numerous patents, making it challenging to locate particular search parameters, was improved. The analytical framework we developed can provide a reference for evaluating technologies in the metahuman field using patent data. Several notable aspects of metahuman technology were discovered through the patent analysis conducted in this research. These findings provide theoretical references for R&D enterprises and governments to comprehensively grasp the status quo of the field and make strategic decisions. The patent application trend in patent priority countries represents the overall scale of technology R&D, current patent holdings, and international market layout capabilities of different countries. The US was the first to explore related metahuman technologies, followed by Japan, but Japan's overall scale was far from that of the US, and it was quickly overtaken by South Korea and China. The patent trends revealed that, since 2017, patenting advantages shifted to China, which is currently leading the patent share by a large margin compared to other countries. In addition, each country has its own advantages in metahuman technologies as a priority country. By comparing and analyzing the key R&D directions and layout of each country, the differences in technology layouts between countries can be identified, which helps to determine the advantages of the national layout and clarify the future layout optimization direction. These analysis results will assist government officials in making decisions for future industrial development of metahuman based on the technology layout and competitiveness assessment. The patent analysis results also revealed several interesting patterns of patenting activity in metahuman technology relating to different modules. The findings of characteristics help enterprises or technology developers to assess and grasp the evolutionary trend of key R&D directions. In addition, the results are useful for investors to identify the possibility of new technology investments in a predictable manner to avoid risks and maintain sustainable prosperities. It is observed that some R&D directions have also evolved from key R&D directions to non-key R&D directions. For example, information collection was a key R&D direction in the early development stage, but has ceased to be a key R&D direction since the rapid rise of development. In addition, information collection, analysis and decision, recognition and perception and modeling and rendering technologies have undergone the process of initial development and rapid development, and were key R&D directions before 2000, but the number of patent applications since then has shown a deceleration and they have ceased to be key R&D directions. In addition, R&D enterprises continue to pay more attention to the two key directions of character generation and synthesis and display. The number of patents belonging to these two modules has increased significantly, and the R&D direction has gradually expanded. At present, their development is currently accelerating. The synthesis and display module was observed as the most active in respect of filing metahuman patents, indicating that the technologies belonging to this module have always shown good momentum in respect of development. Thus, it is a key research and development direction in terms of enterprise sustainability. While intelligence-driven has not demonstrated a rapid development trend, it is most likely to be the next major technological breakthrough point. 5.3. Limitations and future research directions. This research has the following limitations, which can be investigated further in the future. Firstly, future work could examine different types of patents, for the purpose of providing a more comprehensive picture of technical advancement. Secondly, we investigated the technological structure and development level of Metahuman, from a modular perspective. However, the quality of integration between modules could influence a metahuman's final quality. The integration between technologies and its impact also needs to be taken into consideration in the future. Thirdly, the development trends of Metahuman were primarily analyzed from the dimensions of time, product modules, and country distribution. In the future, the interrelationships among technologies, such as co-citations and co-occurrences, can be further analyzed, to enable a deeper understanding of metahuman development and to make suggestions that are more appropriate in reality.